everyone, welcome to my YouTube channel Erudispace. I am Dr. Mohanty, and today we'll discuss about the Vapour compression refrigeration cycle with superheated vapor before compression. So in the previous 3 lectures we have discussed in details the Vapour compression refrigeration cycle with dry saturated vapor after compression, Vapour compression refrigeration cycle with wet vapor after compression, and Vapour compression refrigeration cycle with superheated vapor after compression. So I will draw the temperature entropy and pressure enthalpy diagram to explain all the thermodynamic processes in details. So first I will draw the TS or temperature entropy diagram, and after that I will draw the pressure enthalpy or PS diagram. These 2 lines actually represent the saturated liquid line and saturated vapor line respectively. In PS diagram, this represents the saturated liquid line and this represents the saturated vapor line. 1, 2, 2 dash, 3, 4, 1 dash. This represents the compression process which takes place in the compression. This represents the condensation process which takes place in the condenser. This represents the throttling process which takes place in the refrigerant control valve or throttle valve. And this is the evaporation or refrigeration process which actually takes place in the refrigerator or evaporator. And whatever is being shown in TS and PS diagram actually refer to the condition of the refrigerant, which is the working substance and flows through all the components like compressor, condenser, expansion valve or refrigerant control valve, as well as the evaporator. Now, we'll analyze the different processes. The refrigerant enters the compressor at condition 1, and this is a condition where it is already in superheated state. This refers to your saturated liquid line, this refers to your saturated vapor line. Before this it is all liquid and after this it is all vapor. And we do represent this as a superheated region, and this is a combination of liquid and vapor. Now, when it enters the compressor, the refrigerant is already in a superheated state, and from superheated state 1 it is compressed to superheated state 2, and during the compression process both the temperature as well as the pressure are significantly raised. After that it is taken to the condenser, and in the condenser the heat removal takes place in 2 stages. 2 dash represents the sensible heat removal, where the heat removal to the surrounding cooling medium takes place, and this is a sensible heat transfer. That means the refrigerant changes from superheated state to dry saturated state represented by 2 dash, and after that it is latent heat removal. As a result it gets converted into liquid refrigerant. So 2-3 represents the condensation process where we have the latent heat removal. So if you consider the total condensation process 2-3, it is an isobaric process, but it is not an isothermal process. 2-3 is an isothermal process, but not 2-2. After that, the refrigerant is taken to the refrigerant control valve or your throttle valve, and there it undergoes unrestrained expansion. And from the figure itself you can make out that after passing through the refrigerant control valve or your throttle valve, the temperature drops from T3 to T4 and pressure also drops from T3 to T4. Now, it is taken to the evaporator or refrigerator, and in the evaporator or refrigerator, the heat that is absorbed by the refrigerant takes place in two stages. First, there will be latent heat transfer from the space to be cooled to the refrigerant, and after that there is sensible heat transfer. So unlike the previous three cycles where the refrigeration or evaporation process is an isothermal as well as an isobaric process, here it is only an isobaric process because although 4-5 is an isothermal isobaric process, 1-1 is not an isothermal process. This is not 5, this is actually 1-. Now, this is the way actually the vapor compression cycle with superheated Vapour compression works. Repeatedly I have been saying that as far as the working is concerned, the processes like compression, condensation, then throttling and evaporation are same in all the processes. We segregate into different categories depending upon the condition of the refrigerant. Like your previous cases also, here during the throttling process no work is obtained because this is an unrestrained expansion. So the work done will be the work done in compressing the refrigerant in the compression, and as far as the work done, total work done, it is same as the work done in compressing the refrigerant in the compression. Now, what will happen to the coefficient of performance or COP? That will be the ratio between the refrigerating effect divided by work done. So it is entering the evaporator refrigerator at 4 and it is leaving at 1. So the refrigerating effect is H1 minus H4 and the work done is H2 minus H1, that is the enthalpy difference in the compression. It is entering at 1 and leaving at 2. All of us know that throttling is an isoenthalpic process. So H4 may be substituted by H3. So it becomes H1 minus H3 divided by H2 minus H1. As point 3 is lying in the saturated liquid line, it may be represented by HF3. So it is H1 minus HF3 divided by H2 minus H1. Now, both point 1 and 2 are lying in the superheated region. So H1 is equal to H1 dash plus specific heat at constant pressure times the degree of superheat, that is T1 minus T1 dash. Similarly, H2 is equal to H2 dash plus specific heat at constant pressure times the degree of superheat T2 minus T2 dash. And you need to know the degree of superheat either here or here. That means either the difference between T1 minus T1 dash or T2 minus T2 dash should be known to us to find out the coefficient of performance. Because if you know any one of those, you can find out the other one, because all of us know that 1, 2 is an isentropic process. So S1 is equal to S2. S1 is nothing but the entropy corresponding to 1 dash plus Cp ln T1 dash Cp ln T1 by T1 dash. Similarly, S2 is S2 dash, that is entropy corresponding to this point 2 dash plus specific heat at constant pressure times ln T2 by T2 dash. So if one of those values is known, the other value can easily be find out. If you know 1, you can find out 2, and if you know 2 also, you can find out the value of 1. And once you substitute these values, you can easily find out the coefficient of performance or COP of the cycle. So I sincerely believe that your concept about the vapor compression refrigeration cycle with superheated vapor before compression would be crystal clear after watching this video. But still, if you have any doubt related to this, please do put questions so that I will try to answer. I would request you to subscribe to my YouTube channel Erudispace if you have not done so till now. I would further request you to share this video with your friends and relatives to improve its visibility. Thank you very much for your cooperation. Hope to see you soon for another lecture on my YouTube channel Erudispace.